All right, so section 11.3, it's on area of polygons, so it's kind of any shape. We're going to talk about a couple specific ones today, and then do some what's a little bit more like introductory to what we'll need to use for tomorrow. So first thing, area of a rhombus and kite. So let's review. It's been a while since I think it was chapter 7. A rhombus has 4 congruent sides, and a kite will have 2 pairs of congruent sides but not opposite sides. So if opposite sides were congruent, then we have a parallelogram. But a kite is consecutive sides, you could say also, because the 2 here on the left and the 2 here on the right. Okay, so the area for both, it's pretty simple actually. 1/2 diagonal 1 times diagonal 2. So not the greatest picture, that's okay. So sometimes they'll be written like this. So it's kind of saying like from top to bottom is 8. And then from left to right is 6. It's kind of hard when they put them in like the middle like that to label them, you know, so that the whole thing is 8 and the whole thing is 6. Like, is it talking about this part or that part? So oftentimes you will see the dimensions written like that, or they label each specific like part. So you could see it like 4 and 4 and 3 and 3. So then you just add them together. So very simply, 1/2, 8, 6. So the one common mistake that I see, if there is one, is distributing like you do 1/2 of 8 and 1/2 of 6. So you can't do that. There's only one place where the 1/2 is. You get 1/1/2. So you get to do half once. So you can do 1/2 of 8, then times 6. You could do 1/2 of 6, then times 8. You could do 8 times 6, and then do half. You just get to do half one time. I think the best way is to do half of the biggest number, and then multiply the other one. So whatever dimension you have, meters squared, feet squared, inches squared, you need to write that down. Okay? All right. And then for kite, it's the same principle. So let's say, you know, it's, it could be 10, and let's say 7. So, you know, if you had the diagonals in there, like, you know, maybe it says, oh, that one's 2, and that one's 8, and that one's 3.5, and that one's 3.5. So those add up to 7 and to 8. So 1/2, 10, and 7. So this one can't do, well, you can do 1/2 of 7, it's 3.5, but if it's an odd number, you don't really necessarily want to do that. But 1/2 of 10 is 5, times 7 is 35, feet squared, inches squared, whatever the measurement is. Okay, so the kite and the rhombus, there's just 2 questions each there. Okay. All right, so then we're going to start talking about, and these are all what's called regular polygons. Okay, which means all sides and angles congruent. Okay, so what we're going to talk about for the rest of this lesson and tomorrow all deal with regular polygons. This does not work if they're not regular. We'd have to do something else. And we're only going to talk about regular ones. Okay, so and the context of the regular like polygons is going to be that you can draw a circle around the outside of the polygon. So this is probably not going to work out great just because trying to do that and then also do a circle a lot better than I thought it was going to be. It helps with like some of the like questions that we're going to have to answer. So we have like a center to this circle. And so one of the things that it's going to ask about is a central angle, which is in the center like of the circle. And so it's really actually pretty simple, but we need these angles. And again, it's more for what we're going to do tomorrow than it is for today. But what's the central angle? Well, it's 360 degrees all the way around the circle. And there's 5 sides to the pentagon that's on the inside. So I'm going to divide by 5. And my central angle is 72 degrees. Okay. If it had 6 sides, we would divide by 6. If it had 10 sides, we'd divide by 10. You know, whatever the number of sides is, that's what you're going to divide by to get the central angle. It's a really key component to like what we're going to have to like work with. Okay. So we also have a radius. You might think like we're dealing with polygons, not circles. And you're right, but we're not right at the same time. The radius, remember, is from the center of the circle to the edge of the circle. So a radius, because we can draw a circle around a regular polygon, is like from the center to one of the vertex or the vertices of the polygon. So each corner of the polygon is going to be, you know, from the center to that vertices is a radius. Okay, and that's another helpful piece of information. Okay, all right, I'm going to draw another. Let's see if I can do a good job again. And then, not quite as good, but that's okay. Another piece of information that's really useful, well, it has to be used because it's part of our problem, is called an apothem. And that is like the distance from the center and straight to like one of the sides. It'll be perpendicular like I drew at the end. Okay, so we're not going to deal with, we're going to eventually deal with finding area, and we need to know that length. Okay, so like our the formula, and I'm not going to write it down today because I'll write it down tomorrow, because today we're not going to need the formula, but the formula is half the apothem times the perimeter. So we need that apothem. And you might think, okay, well then why are we talking about radius and central angle? Well, because sometimes we don't know the apothem, and we're going to have to figure it out, and we're going to need the radius, and we're going to need a central angle and all that kind of stuff. Okay. All right. So the other answer your problems. So you're going to have, like I said, a couple area of rhombus and kites. Then you'll have to just identify in a picture, identify the center of the polygon, identify a central angle of the polygon. What is the radius? What is the apothem? You're just going to look at a picture and identify each part. It's already labeled for you. You just have to read the picture kind of thing. Then you'll have 4 problems that will ask to find the measure of the central angle with given a number of sides. So that's like this piece right here. 360 divided by the number of sides will give you the central angle. Then it's going to ask you to find the angles, and it'll tell you which angles they want you to find. So let me do a problem that'll be similar to what you're going to see. I'm going to do it bigger because it's easier to kind of visualize. And so your picture will look something like this. All right, so it might say to find angle AFE, which is the central angle. And it's 5 sides, it's pentagon like we just did. So AFE would be 72 degrees. Okay, again, divide by 5, divide by 6, divide by 12, whatever the number is for the number of sides. All right, then we might say find angle GFE. So we're looking at that one. Okay, and so all those angles up at the by the central angle, when we draw the apothem in, are bisected. So we're just going to do 72 divided by 2 is 36 degrees. Okay, 100% of the time, no matter what shape it is, on a regular polygon, the apothem will bisect the central angle. All right, so then it might say find, it actually is going to say find angle FEG. So now I'm talking about that one. Well, I know that this is a right angle because it's labeled. And then I know what X is, that's GFE, that's the 36. So I would just do 90 plus 36 is 126. And then subtract from 180 because it's a triangle. So that's going to give me 54 degrees. Okay. And then it might also have, let's see if I did this. And so if I said find angle CFA, so I'm trying to find we'll make it a lowercase a, I'm trying to find that angle. And so really what it wants you to do to kind of notice is, remember that it's 360 divided by 5 is the 72 is the central angle. And how many central angles are there? Well, there'll be 5 because there are 5 sides. If there were 10 sides in a decagon, there would be 10 central angles. That's why we do 360 divided by 10. In this case, 360 divided by 5. So it's going from CFA, that's going to include 2 sides or 2 central angles. So I would do 72 times 2 is 144 degrees. Okay, so your last 4 questions, it'll be all on the same picture like this one. It's going to ask roughly the same questions. It's just not going to be a pentagon, it'll be a different shape. Okay, so one question will be asked for the central angle, whatever the number of sides is, divided, or 360 divided by the number of sides. The next question will be what's like either the left or the right side, or the top or the bottom, depending on how it's drawn. It's bisected. The next question will be find that other angle, add them up, minus 180, or subtract from 180. And then another one will be another angle like this one where you got to look at, well, how many central angles am I looking at? Okay, so there's your kind of introduction, and then we'll actually work on finding the area of polygons tomorrow. All right, have a great rest of your day, and we'll see you tomorrow.